All right, so this is section 5.2, and we are going to be looking at the unit circle in this section. So a unit circle is just a circle with a radius of 1 unit. The equation for the unit circle is x squared plus y squared equals 1 with a center at the origin. And in the unit circle, we are going to be looking at angles in standard positions, so going counterclockwise. And if we have a point on any edge of the circle here, so any edge here, that coordinate xy tells us the cosine value at that angle t and the sine value at that angle t. So the x value is the cosine and the y value is the sine value of that angle. So quadrant 1, 2, 3, and 4 again. And we're going to be evaluating these trig functions if we know a point on the edge of the unit circle. So if you have a trig function with the unit circle here, sine is equal to the y value, cosine is equal to the x value, and cosecant is the reciprocal function for sine, and so it would be 1 over y, the reciprocal of the sine value. Cosine will be 1 over x, again, the reciprocal of cosine. And then tangent will be y over x, and cotangent will be x over y. So if we have some point P, that is the point negative 5/13. And let's see, let's look better. Let's try it. So negative 5/13 and negative 12/13. And I want to plot that point in the coordinate plane, a negative x value, negative y value. This is going to be somewhere in quadrant 3. And my x value, I went over negative 5/13. So negative 5 over 13. And you know what, maybe I'll not use pencil. I think that might show up a little bit better here. Negative 5/13 here. And then negative 12/13. We went down that amount here. Now this is the unit circle, which means the distance around the circle is 1. That means my radius here is 1. So that would be 1 here. And I can go ahead and find my trig values at this point here. And when you're doing these problems, before I even start the problem, list off all 6 trig functions here, and I put the reciprocal function next to its reciprocal. And so sine of this point is, again, the y value. So that'll be negative 12 over 13. And cosine is the x value, so negative 5 over 13. Well, its reciprocal function here, cosecant, is going to be the reciprocal of sine, so negative 13 over 12. And secant is going to be negative 13 over 5. Now remember tangent and cotangent. Well, tangent is y over x. We can see that right here. So my y value is negative 12 over 13 over my x value, negative 5 over 13. I can multiply by 13 over 13. And that's just multiplying by 1. And then my denominators reduce, and I have negative 12 over negative 5, which is positive 12 over 5. So that tells me the value here for tangent, 12 over 5. And cotangent is the reciprocal of that, so 5 over 12. Now, tangent and cotangent are what are called reciprocal or quotient identities. Tangent is equal to the sine over the cosine value, and cotangent is cosine over sine, which is exactly what we just saw up here. Y is the sine value, x is the cosine value. So the sine over cosine, and then cosine over sine. Okay, so these are identities that you will definitely need to have memorized. All right. So this unit circle here, we're going to spend some time talking about this unit circle, and I'm going to color code it again, kind of like I did in the previous video. But before I do, Again, this is quadrant 1, 2, 3, and 4. And when we're talking about where different trig functions are positive or negative, you're going to need to know which quadrant they're positive and negative in. So in quadrant 1, all 6 trig functions are positive there. So sine, cosine, tangent, cosecant, secant, and cotangent. In quadrant 2, sine and its reciprocal function are positive, and the other 4 are negative. So sine of x and cosecant of x are positive here, and everything else is negative. In quadrant 3, tangent and cotangent are positive, and the rest are negative. So tangent and cotangent are positive, and the rest are negative. In quadrant 4, cosine and secant are positive, and the rest are negative. So we can tell which trig functions are positive in which quadrant. Now, we already went over the 30, 45, 60, and we went over the radians and how to count around the unit circle, so I won't repeat that. That's back in the first video for this chapter. But these coordinates are the sine and cosine values around the unit circle. So the x coordinate here is what cosine of 30 degrees is equal to. Cosine of 30 degrees is root 3 over 2. Sine of 30 degrees is 1/2. And so that's what these coordinates are all the way around the unit circle. The x values are all of the cosine values at these angles, and the y value is the sine value at all of those. So like we did in the last video, I color-coded these angles so that you could see the pattern that they follow. Let's do the 45-degree angles first. So for these 45-degree angles, sine and cosine are equal to each other. They are both square root 2 over 2. So all of these 45-degree angles are all square root 2 over 2. The only thing that changes at each of these 45-degree angles is the positive and negative signs. And again, that's from all the kind of acronym sometimes teachers will teach us. All students take calculus. All of them are positive here. Sine and its reciprocal function are positive here. So the sine value and then the cosine is negative. Tangent is the only one positive here. So sine and cosine are both negative here. And then cosine is positive here, the x value, and sine is negative. So the y value is negative here. And so the x and y coordinates are the same for all of those. For these 30-degree angles here, these pi over 6, where the denominator is 6, they are all root 3 over 2 and then 1/2. The cosine value is root 3 over 2. The sine value is 1/2 for all of the pi over 6 angles. So all of those angles that have a 6 on the bottom all have the same coordinate. The only thing that changes is those positive and negative signs. And again, that's from all students take calculus, which ones are positive, which ones are negative. You can also think through it in relation to the coordinate system. In quadrant 1, x and y are both positive. In quadrant 2, x is negative, but y is still positive. In quadrant 3, x and y are both negative. And in quadrant 4, x is positive, but y is negative. And then all of these 60-degree angles, all of the ones that have a 3 on the bottom, all have the same coordinate as well. And you'll notice that it's the opposite of the 30-degree angles. So there's really only 3 numbers you need to remember: 1/2, root 3 over 2, and root 2 over 2. Okay. So all of these 60-degree positions all have a denominator of 3, and they all have the same coordinate, just different signs. All of the 45s have the same coordinate, and they all have a denominator of 4. And then all of the 30-degree angles all have a denominator of 6 and the same coordinate there. Now, these other coordinates we have here, 1, 0, 0, 1, negative 1, 0, and 0, 1, or 0, negative 1, are just those coordinates on the coordinate plane. If I go over 1 unit, this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. And this is the point 0, -1. These are the cosine and sine values. So sine of 0 radians is 0. Cosine of 0 radians is equal to 1. Again, cosine and sine value, cosine and sine, cosine and sine. This is something you will need to memorize. If you are taking this class as an online class, you won't have a unit circle quiz. If you are taking this as an in-person class, you will have a unit circle quiz where you have to have all of this memorized, the degrees, the radians, and the coordinates around the unit circle. If you're taking this class as an online class, you may be tempted to think, oh, phew, I don't have to have a quiz on this. I don't have to have it memorized. I think that actually handicaps you, that you don't have that accountability. You need to have this memorized just as much as an in-person class, because in calculus, you will have an instructor say, okay, what is sine of 5 pi over 3? And you'll need to just know it the same way you know 2 plus 2. All of this information should be memorized. You should know it as quickly as you can answer 2 plus 2 equals 4. It's not an exaggeration. You really do need to know it that well, because it will become very, very small parts of much larger problems. And you won't be able to think through the larger problems or evaluate problems if you don't have this memorized. Without the unit circle being memorized, you might as well just skip over chapters 5, 6, and 7 now, because there's nothing you can do in those chapters without having this memorized. So I cannot emphasize this enough. Even if you're just taking this class online, you have to memorize your unit circle. You absolutely do. And not just memorize it temporarily. You have to keep it memorized. It should be in your brain and it should stay there. Again, just like 2 plus 2 equals 4. You need to keep this memorized for calculus, Calc 2, Calc 3, other math classes, and beyond. This is not something that will go away. It will be something that you continue to build on. And if you don't know it, you won't be able to build on it. So hopefully I emphasized that enough and convinced you to make sure you put in the time to memorize that unit circle. There are also identities you need to know. These are the even and odd identities. Cosine and secant are both even functions. If you take cosine of negative pi over 4, that's going to be equal to cosine of positive pi over 4. Same thing with secant. Those values are equal. It's essentially like that negative is not important. It goes away. Sine, tangent, cosecant, and cotangent are all odd identities. You have negative theta, and then you can pull that negative out, and you will have that be equal to sine of theta, negative sine of theta. So that's one of the properties for sine, tangent, cosecant, and cotangent. These are the reciprocal identities, and it tells you the relationship between the different trig functions. So sine of theta is equal to 1 over cosecant of theta. Cosecant of theta is equal to 1 over sine of theta. These two are reciprocal functions. These two are reciprocal functions. And these two are reciprocal functions. They're pairs. They go together. So tangent of theta is equal to 1 over cotangent. Cotangent is equal to 1 over tangent. And those are those reciprocal identities. On the next page, we have some special right triangles. Again, hopefully you learned this in a trig class. I will be going through it quickly as though you have already learned it in a trig class, and we'll kind of expect that you know what I'm talking about. So sine is defined as opposite over hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is opposite over adjacent. If you have the special right triangle, a 45, 45, 90, or if you have a 30, 60, 90, these are what those side lengths are going to be equal to. So if I have a 45 degree, 45, 90 triangle, the legs are root 2 over 2, and the hypotenuse is equal to 1. If I have a 30, 60, 90 triangle, the hypotenuse is equal to 1. The side opposite of 60 degrees is root 3 over 2, and the side opposite of 30 degrees is 1/2. So we're going to fill out all of these values here, and you should be able to do this if these were radians or degrees. I have it written here in degrees, but you'll probably actually be doing this more with radians. So if I was asking you sine of 45 degrees, well, sine is opposite over hypotenuse. So the opposite side, root 2 over 2 over 1. Well, that's just root 2 over 2. Cosine of 45 degrees is adjacent over hypotenuse. So the adjacent side, root 2 over 2 divided by 1 is root 2 over 2. And tangent, remember tangent is sine of 45 over cosine of 45. And so anything over itself is going to be equal to 1. Well, the reciprocal functions, cosecant of 45, that's the reciprocal of sine. So that would be 2 over root 2. We don't want to leave a square root in the denominator, so we're going to rationalize that denominator. And multiplying by root 2 over root 2, that's what rationalizing means, get the square root out of the denominator. Root 2 times root 2 is 2, and then 2 root 2. These two cancel, and we are left with root 2. So that's what cosecant of 45 is. Secant of 45, flipping the same thing, I get the exact same thing, root 2. And cotangent is the reciprocal of tangent, and 1 over 1 is still just 1. So those are those 45-degree angles. For 30 degrees, we have, let me zoom out a tad so I can still use those triangles here. Sine of 30 degrees, if I'm taking sine of 30, that would be the opposite over the hypotenuse, so 1/2 over 1, that would be 1/2. Cosine of 30 degrees is the adjacent over the hypotenuse, so root 3 over 2. And then tangent of 30 degrees is opposite over adjacent. Well, let's do this kind of off to the side here. Opposite is 1/2 over root 3 over 2. I can multiply by 2 over 2, and those denominators reduce. And I have 1 over the square root of 3. I need to rationalize, so I'll multiply by root 3 over root 3. And then that becomes the square root of 3 over 3. Cosecant of 30 is the reciprocal of 1/2. Well, flipping 1/2, that is 2. Secant of 30 is the reciprocal of cosine, and flipping that, that becomes 2 over the square root of 3. But I need to rationalize, so root 3 over root 3 becomes 2 square root 3 over 3. So 2 square root 3 over 3. And then cotangent of 30 is the reciprocal of tangent. Remember, tangent was 1 over the square root of 3 before we rationalized. Flipping that, that would just be the square root of 3. And then doing all of the 60-degree angles, it's going to be very similar. You'll see their relationship here to the 30s. And so if I have sine of 60, so now I'm orienting myself from the 60-degree angle, the opposite over hypotenuse would be root 3 over 2 over 1, which is just root 3 over 2. Cosine of 60, so from 60, the adjacent over hypotenuse would be 1/2 over 1, which is just 1/2. Tangent of 60 would be the opposite over the hypotenuse, so root 3 over 2, or not hypotenuse, opposite over adjacent. Root 3 over 2 over 1/2. And again, I can multiply by 2 over 2. And those cancel, and I'm left with just root 3. And then cosecant of 60 is the reciprocal of root 3 over 2. Now, we just found the reciprocal of root 3 over 2 when we did it over here, and we got 2 root 3 over 3. So I'm going to borrow that work over here. And then secant of 60, well, if cosine is 1/2, the reciprocal of that would be 2. And then tangent is root 3, and the reciprocal of that would be 1 over square root of 3, which we just rationalized over here, and we got root 3 over 3. So you see these are called cofunctions here. Cotangent and tangent, tangent of 30 is the same as cotangent of 60. And sine of 30 is the same as cosine of 60. And sine of 60 is the same as cosine of 30. These are called co-functions. And we'll see these formulas or these identities written out in our notes momentarily. At the bottom of this page here, you see what are called the Pythagorean identities. And these identities are some of the most important identities that you will use in this class, as well as in Calc 1, 2, 3, and 4, or not 4, and so on. So these are called the Pythagorean identities. You can memorize the first one, and then you can find the other two from that first equation. So sine squared t plus cosine squared t is equal to 1. When you see sine squared t, that means the sine function squared. Those mean the same thing. We just use the notation like this. Now, if I have this first equation here, and I divide sine squared t plus cosine squared t, and that equaling 1, if I divide every term by sine squared, oh, you can't see that. Let me do this in non-pencil. Let's see. So if I have sine squared t plus cosine squared t equals 1, and I divide each of those terms by sine squared, sine over sine is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared t would be cosecant squared t. Well, that's this bottom formula. Okay. Now, if I write the whole thing out again, sine squared t plus cosine squared t equals 1. And I divide every term by cosine squared t. Well, sine over cosine is tangent. Cosine over cosine is just 1. And 1 over cosine squared is secant squared t. And that is that second formula. So if you use that first equation and you divide everything by sine, you get that bottom one. If you divide everything by cosine, you get that middle equation. So as long as you memorize the first one, you can reason through and think through what the other two are. And I think this is a good stopping place for this video. We will finish out this section in a part 2 video.